Good afternoon, or good morning, or good night, wherever you're at. My name is Gabriel Chapman. I am a solutions architect with SimpliVity Corporation. I am going to be basically talking to you today about using atomic building blocks and laying the foundation for your infrastructure today. I know this is an OpenStack conference, and so I'm basically going to be talking about some of the underlying hardware architecture that you would leverage. Today in the data center as a whole, I think we all have faced this major issue is that there's two big challenges. We have a significant amount of complexity inside the data center, lots of different moving parts, lots of little management portals, lots of different tools that we use on a day-to-day basis. And there's also a significant issue around data growth inside the enterprise as a whole. We're not getting rid of any storage anytime soon, right? So when we look at what we consider to be the legacy stack, from an infrastructure standpoint, it is something that creates a significant amount of complexity inside the organization. We have servers with virtualization or some kind of hypervisor level and an orchestration layer and data protection applications and switches and storage arrays and backup appliances and gateways. All of these different technology pieces. Really under the covers, what are we looking at? It's a bunch of commodity x86 resources with Linux and a management console and a support contract and all of these different challenges that are associated with it. They're disparate products, they're not interconnected, there's no interconnected awareness around them. They have long deployment cycles. Each one has a support structure that you have to manage and deliver with. There's a lack of agility. Trying to deploy this stack of physical assets into lots of different disparate locations is a challenge, right? And obviously, the vendor disparity issue can be a challenge as well, because I know, just like you, that I love getting calls at 2 in the morning when I have 3 vendors on the phone. They're all fighting with each other and no one taking responsibility. So what we try to do at SimpliVity is transition you in your organization from the legacy stack into what we term more of an atomic building block or the ultimate Lego for your data center. So we consolidate all of that complexity down into a single 2U appliance that scales. And it's a linear scale and a linear performance that go hand in hand as we add the systems together. So it's a scale-out architecture, and it's essentially everything you need to run or start your data center in a 2U appliance. And we start from there and go. Really, inside the technology, what really powers everything below it is this twofold for us. It's what we call an Omni Stack. It is a hardware aspect that does deduplication, compression, and optimization of data in real time, once and forever. Essentially, we only write unique data. We only write it one time. And it's done throughout the life cycle of the data, so there's no hydration, rehydration, dehydration process that goes along. As a unique block is written, it will be compressed and deduplicated and laid down to hard disk. Inside the system as well, what the marketing terminology that we use or we leverage is called hyperconvergence, and that's really taking that stack of technologies and collapsing it down into a single appliance and kind of creating a single shared pool of resources per se, instead of multiple disparate pools that you're managing from a different point. And also a global management aspect. So there's one pane of glass, one single screen to manage your infrastructure and use that. And then we write policies around data protection at the virtual machine level or at a globally federated level as well. So if I have a platform that's in multiple disparate data centers across the globe, I can manage them all from any one given key management point inside my operation. So simplify your data, your infrastructure, and your operations all in one box. So how do we do all this, or at least how are we replacing that complexity with what we call simplicity, right? So when the appliance comes into the organization or operations, what it does is it becomes the primary storage in virtualized environments. So you don't have a storage array anymore. We become the storage array. When it comes to WAN optimization, so there's appliances today that you can go out and purchase. There's virtual machines you can go out and purchase. They can use and do data compression and algorithms to basically make WAN optimization faster. We already do that inside the platform simply by the fact that I never have to redundantly send data ever. So I only send unique blocks once, and then I'll never have to send them again. So once the data is common on both sides, it never has to go again. So it doesn't take a whole lot of WAN optimization to send a few megabytes, right? Deduplication appliances, they are prolific inside many data centers today. VTL devices, any kind of device you're offloading your backup onto is in a platform. Essentially, we replace that technology because it's built and baked into our solution. We already have deduplication as the primary aspect of all the data that comes into our platform, and you can do it across multiple OmniCubes, provide high availability. You can replicate it offsite to another location with an OmniCube platform, or you can go directly today into a cloud space as well for long-term DR. So what we see is customers putting smaller pipes between their data centers, and so therefore leveraging and reducing ongoing recurring costs that are associated with bandwidth. Not cheap. Cloud services, so there are cloud gateways for lots of customers out here today who want to integrate for long-term DR capabilities, or just even to store workloads someplace else offsite or off premises. We have that functionality baked into the platform already. Simply you just download a virtualized instance of this and put it into the cloud space and run long-term DR to the cloud at that point. And inside the system it acts more as a hybrid array, so we have SSD for performance reasons. And so specific SSD appliances we don't necessarily need because we can scale to get the performance of pretty much any platform that's out there today. So obviously high availability for inside our platform is built in natively for the platform at a data level. Depending on what hypervisor you're using, you can use different types of high availability as well. So if, let's say in this case, it's ESXi as a hypervisor, you can essentially have the box provisioned with ESXi preloaded on it and essentially spin up a virtual controller, and now you're ready to start provisioning your virtual machine workloads, do a storage vMotion or some kind of migration point to get your data onto our platform, and here you have the nice happy SimpliVity super data center, right? But we know that doesn't apply to everybody. So the platform itself is flexible in its scale out and its scale in as well, which is kind of neat. But it's also an open architecture, so it may not be ready for you today to come in and simply rip and replace all your infrastructure and use an OmniCube platform. Today I can actually take two OmniCubes and directly connect them together, right? I don't need any 10 gig infrastructure. Once I scale past that, right, if we come out with a different flavor of an OmniCube or a different type of platform in the future, it's very simple for us to simply just add them together or join the federation and have them connect in and then simply scale those resources. Also, big pain point for a lot of organizations is data migration strategy. When you do have to depreciate an asset, what happens when you have to take something out of the data center in year 5 or year 3? For us, it's a simple right-click operation, and it reprovisions the data equally across the other nodes, and then I can simply depreciate that asset. Or maybe I'm shrinking a footprint of a facility, or I need to ship a unit off someplace else to leverage it in another location. That's simple. It's all right-click. It's go grab a cup of coffee, come back, and you're done. Also, the open architecture aspect is one such that today we can actually take any commodity x86 resource and directly connect it to us. We leverage NFS in the back end for storage, and so therefore we basically expose our storage layer to your existing hypervisor environment. You can simply run external systems as a compute node, as a compute system, right? So an OmniCube, a base OmniCube comes with roughly 20 to 40 terabytes of usable storage capacity, 2 sockets, 24 cores, half a terabyte of RAM. That's a pretty significant, robust platform in and of itself, but perhaps you need to fine-tune your compute aspects a little bit differently. 3 OmniCubes here, you have roughly 60 to 120 terabytes of storage capacity, but maybe you need more compute. So connect any of your commodity x86 servers to us. Get investment protection with the technology you've already paid for and want to leverage continually, and connect it to us. And then all of our benefits within the platform are then imparted to those machines. They simply become dumb compute nodes that just run CPU and memory while all run top of our storage. So I think that's pretty much all I had to do today. Hope everybody had a great time at the OpenStack conference. Thanks to vBrownbag for having me on board, and party on.